Good morning everyone. Today we will be solving few questions based on continuity and differentiability. Let us move on to our first question. Let me read the first question. If f of x is equal to 3 sin pi x divided by 5x at x not equal to 0 and 2k at x is equal to 0 is continuous at x is equal to 0, then the value of k is. So in this question, we are supposed to find the value of k such that this function f of x is continuous. Since it is already given that the function is continuous at x is equal to 0, see, when do we tell a function is continuous? The LHL should be equal to RHL and that should also be equal to f of a. So in this question, a is 0. Along with that, at x is equal to 0, f of x is 2k. So we can consider f of 0 as 2k and we will be finding the value of k. So since the function is continuous, we can write f of 0 is equal to limit 3 sin pi x divided by 5x as x tends to 0. Why? Because they have given us that f of x is already continuous at x is equal to 0. Now, if we apply limit for this function, see, sin 0 is 0, and if we apply limit to the denominator, that is 5x, 5 into 0 is again 0. So this is of the form 0 by 0. So here what do we do is, we will be applying LH rule. So what do we do in LH rule is, we will be differentiating the numerator and the denominator separately, and later we will be applying the limit. So here limit as x tends to 0. So once I differentiate this 3 sin pi x, I'll be getting 3. 3 will be taken as it is because 3 is a constant. Now we'll be differentiating sin pi x. See, this is a form sin ax. So the differential of sin is cos. So again we need to differentiate pi x. So differentiating pi x gives us pi divided by differential of 5x is 5 into 1. So now if I apply limit here, this becomes 3 cos pi into 0 multiplied by pi divided by 5. So cos 0 is 1. So 3 pi divided by 5. So we already know f of 0 is 2k. So 2k will be equal to 3 pi by 5, or k will be equal to 3 pi by 5 into 2. So the value of k becomes 3 pi divided by 10. So here our option B is correct. 3 pi by 10 is the answer. So now let us move on to our next question. Now in the next question it is given that f of x is 3x minus 8 at x less than or equal to 5 and 2k if x is greater than 5 is continuous. Find k. So even in this question we are supposed to find the value of k. Now in this question it is given that f of x is 3x minus 8 if x is less than or equal to 5. So our f of 5 will also equal to 3x minus 8, and since 2k if x is greater than 5, we will be considering this 2k while we are finding the value of RHL. Since it is given that the function is continuous, I'll be able to write this as LHL will be equal to RHL, and this will be again equal to f of a. In this question, a is equal to 5. So how will I be able to write the LHL? See, for the LHL, we will be considering 3x minus 8. Why? Because x is less than or equal to 5. So this will be equal to limit as x tends to 5 minus f of x, and RHL will be limit as x tends to 5 plus f of x, and this is again equal to f of 5. So our LHL is 3x minus 8. Along with that, our f of 5 will also be found at 3x minus 8. So I'll be able to write this as 3 into 5 minus 8 will be equal to limit as x tends to 5 plus 2k. Since this term is independent of variable x, even if we apply the limit, 2k will remain as it is. So 5 3s are 15 minus 8 will be equal to 2k. Therefore, the value of k will be 7 divided by 2. So here the value of k will be equal to 7 divided by 2. The next question is, the function f of x is equal to x, where f of x denotes the greatest integer function is continuous at. So in the given options, that is a is minus 2, b is 1.5, c is 4 and d is 1. In the given options, we are supposed to find where f of x, that is the greatest integer function, is continuous. See, we already know that the greatest integer function is continuous at r minus z. Now what do we mean by r minus z? We will be considering the real numbers minus z. So z is integers. So wherever the integers are present, this greatest integer function is not continuous. So in the options, we can see minus 2 is an integer, 4 is also an integer, 1 is also an integer. So at minus 2, 4 and 1, this function, that is the greatest integer function, is not continuous, and only at 1.5, that is a real number, it is continuous. Therefore, the greatest integer function is continuous at 1.5. So here the option will be B, 1.5. Why? Because the greatest integer function is always continuous at r minus z. Let us move on to our next question. If y is equal to log of 1 minus x square divided by 1 plus x square, then dy by dx is equal to. So here the options are also given. See, in this question, we are supposed to find the derivative of the given function y is equal to log of 1 minus x square by 1 plus x square. So we already know that the derivative of log of x is 1 by x. So let me consider y as log of 1 minus x square divided by 1 plus x square. We will be solving this problem by applying the chain rule. So differentiating with respect to x, dy by dx will be equal to, see, the differential of log x is 1 divided by x. So we will be considering this whole function as x. So 1 divided by 1 minus x square divided by 1 plus x square. Since this is something else other than x, we will be differentiating this also. Now this is of the form u divided by v. So we will be applying a quotient rule here. So the quotient rule tells us, first we will be considering the square of denominator and denominator into differential of numerator. So if I differentiate 1 minus x square, I'll be getting 2x with the negative sign as it is, minus of numerator, and will be differentiating the denominator. That is, the differential of 1 is 0, differential of x square is 2x. Since this is of the form 1 by denominator, So I'll be able to take this up. So this becomes 1 by x square, 1 plus x square divided by 1 minus x square. So we will be simplifying this to get the exact value. So I'll be able to write this as minus 2x cube minus 2x plus 2x cube divided by 1 plus x square the whole square. So this 1 plus x square and this square will get cancelled. Along with that, minus 2x cube plus 2x cube will also get cancelled, and we are left with 1 by 1 minus x square multiplied with, see, minus 2x. So we'll be getting it as minus 4x divided by 1 plus x square. Now these two terms, if we observe both the terms in the denominator, that is 1 minus x square and 1 plus x square, this is of the form a plus b into a minus b. So I'll be able to write a plus b into a minus b as a square minus b square. So this becomes minus 4x divided by 1 square minus x square the whole square. So this will be equal to minus 4x divided by 1 minus x to the power 4. So this is our required value of dy by dx. So our option is C. Minus 4x divided by 1 minus x to the power 4 is the required answer. So our next question is, if x is equal to a cos cube theta, y is equal to a sin cube theta, then 1 plus dy by dx square is. So in this question, first we'll be finding the value of dy by dx, substitute the value, and we will find the value of 1 plus dy by dx the square. Now if we observe these two equations, x is equal to a cos cube theta and y is equal to a sin cube theta, see, both are function of theta. That is, x is also a function of theta, y is also a function of theta. But what we want dy divided by dx. So first thing, see, these two equations can be considered as parametric equations. Why? Because x is also a function of theta and y is also a function of theta. Now if the functions are in this way, we can write dy by dx as dy by d theta. That is, we'll be differentiating y with respect to theta, and dx by d theta. That is, we'll be differentiating x with respect to theta. So if I want to find the value of dy by d theta, I'll be differentiating y with respect to theta. Now this is of the form a into x cube. So even here we will be applying chain rule. So this becomes a into, see, x to the power n is n into x to the power n minus 1. So x cube will be 3x square. So I'll be applying the same thing here. Sine cube theta can be written as 3 sine square theta. Now I need to even differentiate sine theta. So we already know the differential of sine theta is cos theta divided by, along with that we will be differentiating x with respect to theta. So again, a is a constant, cos cube theta can be written as 3 cos square theta. Along with that, the differential of cos theta is minus sin theta. So what all we can cancel? A and A will get cancelled. 3 and 3 will also get cancelled. This square and sin theta, this square and cos theta will get cancelled. And we are left with minus of sin theta divided by cos theta. Now sin theta by cos theta can be written as tan theta. Along with that we have a negative sign. Let us write as it is. So dy by dx is minus tan theta. But what we want the value of 1 plus dy by dx square. So 1 plus minus tan theta square. So this will be equal to 1 plus tan square theta. So we already know 1 plus tan square theta can be written as secant square theta. So the value of 1 plus dy by dx square is secant square theta. Therefore, option C is the right answer here. Now let us move on to the next question. What is given in our next question is, let f of x is equal to x minus 1 by x, then f dash of minus 1 is. So here first we need to find the derivative of f of x, then we'll be substituting the value minus 1 to get the value of f dash of minus 1. So let me consider f of x first, that is x minus 1 divided by x. So f dash of x is differential of x is 1 minus of differential of 1 by x is minus 1 by x square. So again this will be equal to 1 plus 1 by x square. That is our f dash of x. Now what we are supposed to find? We need to find the value of f dash of x at x is equal to minus 1. Therefore at x is equal to minus 1, f dash of minus 1 will be equal to, now how do we get f dash of minus 1? We will be replacing x with minus 1. So wherever x is present, we will be substituting minus 1 there. So f dash of minus 1 will be equal to 1 plus 1 by minus 1 square. So this is 1 plus 1 by 1. So this will be equal to 2. So the value of f dash of minus 1 is equal to 2. So the value is 2. Hence the option is B. So our next question is, for constant a, dy by dx of x to the power x plus x to the power a plus a to the power x plus a to the power a is. So we need to differentiate this and we need to see what will be its value. So let us consider dy by dx of x power x plus x to the power a plus a to the power x plus a to the power a. See, this can be written as d by dx of x to the power x plus d by dx of x to the power a plus d by dx of a to the power x plus d by dx of a to the power a. So first we need to find the differential of x to the power x. So consider, I'll be just considering t as x to the power x. See here, we will be using log to find the value or to find the derivative of x to the power x. So I'll be taking log on both sides. So this is log t will be equal to log of x to the power x. So this again becomes log t. See here, we know log of a to the power m can be written as m log a, and this is to base e. So this becomes x log x to base e. Now we already know the differential of log t is 1 divided by t, and again I should write dt divided by dx. Why? Because we are differentiating this with respect to x. So here again I'll be applying a product rule. First function differential of second function plus second function into differential of first function. So our first function is x, so derivative of x is 1. So this becomes dt by dx will be equal to t into this x, and this x will get cancelled. We are left with 1 plus log x to base e. So dt by dx will be equal to t is x to the power x, 1 plus log x to base e. So this is our differential of x to the power x by dx, that is x to the power x 1 plus log x to base e. So I'll be replacing, and again we should remember this as a formula also. This is an important one. Differential of x to the power x will always be equal to x to the power x 1 plus log x to base e. Now let us move back to our given equation. So d by dx of x to the power x plus x to the power a plus a to the power x plus a to the power a will be equal to, first we will be writing the differential of x to the power x. So differential of x to the power x with respect to x is x to the power x multiplied with 1 plus log x to base e plus, see, differential of x to the power a. Now this is a form x to the power n. So derivative of x to the power n is n into x to the power n minus 1. So this will be a into x to the power a minus 1. Now this is a form a to the power x. So derivative of a to the power x is a to the power x log a. Now this a to the power a is a constant. So derivative of constant will be equal to 0. So our final answer will be x to the power x 1 plus log x to base e plus a to the power x to the power a minus 1 plus a to the power x log a. So this is our final answer. So once we see the options and which will be the right one, so option B is the correct one. X to the power x 1 plus log x plus a into x to the power a minus 1 plus a to the power x log a. So the option is B. So our next question is, if u is equal to sine inverse of 2x by 1 plus x square and v is equal to tan inverse of 2x by 1 minus x square, then du by dv is. See, we need to find the differential of u with respect to v. See, if we observe the equations u and v, see, these two are parametric equations. Why? Because u is also a function of x and v is also a function of x. So first thing, we'll be differentiating u with respect to x and v with respect to x, and we divide them and we'll be getting the value of du by dv. Now if we observe u is equal to sine inverse of 2x by 1 plus x square and v is equal to tan inverse of 2x divided by 1 minus x square. See, first we need to differentiate this. Now if we want to differentiate this with respect to x, first thing we'll be writing the derivative of sine inverse of x, that is 1 by root of 1 minus x square. Along with that, we'll be applying chain rule and we'll be solving this. That becomes a very tedious process. So we can actually use substitution method to find the derivative here. So I'll be taking x as tan theta. Now if I consider x is equal to tan theta, from here the value of theta will be tan inverse x. So we will be using this in the given equation. So if I put x is equal to tan theta, our u will be reduced to tan inverse of 2 tan theta divided by 1 plus tan square theta. So we already know 2 tan theta divided by 1 plus tan square theta is sine 2 theta. Now sine inverse of sine 2 theta will give us 2 theta. Now what is the value of theta that we have wrote? Theta will be tan inverse x. So u is 2 tan inverse x. Now if I differentiate this u with respect to x, that is du by dx, the differential of tan inverse x is 1 by 1 plus x square. So du by dx is 2 divided by 1 plus x square. And we'll be doing same for v also. I'll be substituting the value of x as tan theta even here. So v is tan inverse of 2 tan theta divided by 1 minus tan square theta. See, even here 2 tan theta divided by 1 minus tan square theta can be replaced with tan 2 theta. So this becomes tan inverse of tan 2 theta. So tan inverse of tan 2 theta gives us 2 theta. So the value of theta can be replaced with tan inverse x. So this is our value of v. Now if we differentiate this with respect to x, we get dv by dx, that will be again equal to 2. Differential of tan inverse x is 1 by 1 plus x square. So what we want? We want du by dx. So du by dv will be equal to du by dx divided by dv by dx. So du by dx is 2 divided by 1 plus x square. dv by dx is also 2 divided by 1 plus x square. So this can be reduced to 2 divided by 1 plus x square multiplied with 1 plus x square divided by 2. So this 2 and this 2 will get cancelled, and 1 plus x square will also get cancelled, and we are left with 1. So the value of du by dv is 1. So the correct option is C.